So far, we learned two methods of finding the concentration of a solute in a solution. The first one was where we had the mass of the solute divided by the total volume of the solution in milliliters. We call that the mass volume method. And the other was where we had the grams of the solute in the total grams of the solution. We call that the mass method. But now we are going to look at another method which is way more common than the other two which I just mentioned. And this method is based on the molarity or the number of moles of a solute in a solvent. It's very straightforward and yet it is universally used. In fact, most of the bottles ever found in a chemical lab will be labeled using this method. And this method is known as the molarity, where molarity is symbolized with uppercase M and is defined as the number of moles of solute per 1 liter of solution. Moles of a solute divided by the volume of the solution in liters, that's molarity. Here is a problem depicting a solution where you have 5 moles of sodium hydroxide dissolved in 2 liters of a solution. So what is the molarity? We specifically use the word molarity when we talk about concentration found through this method. And so uppercase M being molarity equals 5.0 moles of solute divided by 2.0 liters of solution, giving us 2.5 molar. The pronunciation for this on the right side is molar, M-O-L-A-R, 2.5 molar. Here is another problem. Now this problem actually gives us a situation that you would commonly encounter in a laboratory. If 5.00 grams of glucose are dissolved in 1.00 times 10 to the 2 milliliters of solution, calculate molarity M of the glucose solution. So why is this the common situation you find in a lab? Because in a lab you may obtain 5 grams of glucose and dissolve it in 100 ml of a solution. And then you may want to know what's the concentration. So what do you have to do? You first have to convert the grams to moles using the molar mass conversion factor. The molar mass of glucose happens to be 1.80 times 10 to the 2 grams, 180 grams. And that's the mass of 1 mole. And so the gram gets cancelled out and we get number of moles for glucose equal to 2.78 times 10 to the negative 2 moles. And then it's as usual what we saw previously. We divide this number of moles by the volume of the solution. However, the volume, keep in mind, was in liters. And remember that it's not in milliliters. In the previous problems where we had mass volume rather, percent mass volume, the volume was in milliliters. But when it comes to concentration given in molarities, the volume is in liters. So this is the total number of liters, and then we can find our concentration as 2.78 times 10 to the negative 1 molars. Now here is a problem where we are given the concentration of acid, sulfuric acid, as 0.750 molars, and we are told that the solute, which in this case would be sulfuric acid itself. Well, sulfuric acid is a compound H2SO4 dissolved in water, making it an acid. So if we dissolve 0.120 moles of our sulfuric acid H2SO4 in certain amount of water to produce 0.750 molar of sulfuric acid, what is that volume of water? What is that amount of water? So we know that if 0.750 molar is our concentration, that was produced by dissolving 0.120 moles of sulfuric acid in certain volume of total solution. And then it's just rearranging this equation, multiply both sides by x liter of solution, cancelling it out on this right side, and then dividing both sides by 0.750 molar H2SO4, cancels this out from the left side and moves it to the right. which produces this form, and then we can find out the value of the volume of our solution as 0.160 liters.